Okay, so those of you who've not done day one activity yet, lesson day one, homeschool lesson day one. So the task was calculating trusses, and just to guide you, um, I put up I put up a demonstration chat of how to get started. So we went over, like it said in the assignment here, agenda number one, said if you recollect, for static determinancy, 2j equals to n plus r. J will be number of joints when you have trusses, right? So when you multiply that by two, number of joints, if you count number of joints you have, and then M will be number of members you have, and the R here will be number of resultant forces or reaction forces. So the assignment you had to do, which started with a task, I'll go straight to that. So we went over trusses here, and you have formulas to use, right? The first one will be for there to be static equilibrium. Um, the For static equilibrium, the total forces equals to zero. On the x-axis, total forces on the y-axis has to be zero, and the other one will be total moments will be equals to zero. Okay, so starting with the total moments, and this is solving using the moments, right, like it says here. So when you have a truss or a set of trusses that's pinned at point A, and then you have the joints here, A, B, C, D, and E. So you have a load applied here at 800. Then you want to calculate for the moments. So this is step one of the calculations you need to do. So calculating for the moments means you're calculating distance times load of forces, right? You have only one force applied here. You're going to have a reaction force here. You're going to have reaction forces x and y axis this way. Now, because this is not a fixed point, you only have a reaction force acting on the y-axis going up. And now also something to remember, like it said here, forces that tend, if you hold this point down, forces that tend to make it move in the anti-clockwise direction are positive. Forces that make it go down in the clockwise position are negative, right? So this will create a clockwise momentum or torque, which will be negative, right? While the reaction here is holding it up, so it's tending to make it go anti-clockwise, which is positive. Okay, so now to get started, the calculation we have here is now at the points AX, AY, and CY, um, so those are the reaction forces. Now something to note, right? Any any point at which the reaction force has no distance, right? It doesn't tend to be able to create momentum. So that will be a zero force when you're calculating for moments, right? So this one here is going to be like a zero, and then you only have to calculate for this one, okay, and this other one here. So making your calculations here, I already explained everything that's written here already, right? Um, when you're making your calculations, moments is force times distance. So you add all the rotational forces using the positive and negative sign, depending on if it's going to create clockwise torque, which is rotation, or anti-clockwise rotation. So adding all that, what you're going to have will be 800 times the distance, which is for this one here, this 800 times that distance from the point, from the fixed point. So 800 times 5, that gives you 40, that gives you 4,000, right? And then that's going to be creating clockwise, so it's going to be negative. So you add that to this unknown, which is going to be multiplied by 5 plus 5 because you're calculating the distance from this point. That's going to be unknown, which is cy times 10, and that's going to be positive because it's making the trusses turn anti-clockwise. So you add 4,000 negative, and then cy times 10 positive, which is 10 cy, right? Now from your math, when you solve like in math, you're going to have 4,000 negative 4,000 pounds feet equals to minus 10 cy pounds feet. So now when you substitute for y, trying to make y the subject of the equation, you're going to have to now basically how you do that is you divide both sides by minus 10. That gets rid of the y on both sides, and that makes cy stand by itself. It gets rid of the minus 10 on both sides when you divide minus 10 and minus 10 on both sides. So if you divide minus 10 here, it's going to leave you with cy. If you divide by minus 10 here, it's going to give you, you get rid of the minus, then you strike out 0 from the decimal and the numerator. So it's going to leave 400 equals to cy. Now that gives you cy equals to 400 pounds feet. Okay. If you recall, now to tie this up to what you guys did on MD Designer, MD Solids, when you look at what you did for MD Solids, this drawing here, which this is a drawing from one of you, I can't remember whose it is. When you look at the drawing, if you look at, you have 400 at that point as well. So that gives you 400, which was what you're looking for, cy, right? 400, and that was 800 like we had in the calculation. Okay, so that explains that, right? So the assignment you had to do was to use that same method I just explained to calculate for this set of trusses. If you have a fixed point here, fax and fay, remember, this is the fixed point. So you're calculating for moments, which is what you're required to do for this step 1. Calculate for moments, right? This fay is at a 0 distance, so it's not able to cause any torque or any rotational motion. So the forces that are causing rotational motion will be this one here, 300 pounds. This is 700 pounds over here. And then this goes in opposite direction, which is unknown. So you have to calculate resolving for moments, right? And like it says here, calculate forces acting on these trusses. Moments of all the forces must total 0, right? So you want to determine which ones are positive, which ones are negative, which I explained already. Okay, so hope that helps, and hope you get to do this assignment and turn it into PowerSchool, into Schoology rather, right? And I will be giving a schedule of when we'll be having meetings, okay? Okay. All right, so that should be that. Try to minimize this a little. And you can email me with any concerns you have. I will be there to respond to any concerns you have. Thank you so much. Hope you're all staying safe from this trying times we have. I hope your families are doing good as well. Yep, I'm always here to help. Thank you. How do I save this? Good, 58, really?